Welcome. In this video lecture, we are going to talk about the logistic regression. So we will first of all see what is the logistic regression is and under what condition we can apply this logistic regression approach. Then we will see what is the difference between the linear regression and the logistic regression. And then we will discuss different types of logistic regressions, and then we will see one example, and using that particular example we will see how we can perform or solve that particular problem using R by applying the logistic regression, and we will try to interpret those results. So let's first of all discuss what is a logistic regression. So basically logistic regression is a statistical and supervised machine learning algorithm which is basically used when we have the dependent variable in a categorical form. Okay, so categorical type means the dependent variable which normally in a linear regression we are writing down the equation y is equal to beta naught plus beta 1 x, okay, plus beta 2 x2 up to so on, right? Beta n xn and error term. So that is the linear regression line where our dependent variable must be having the form of continuous. Okay. But if our dependent variable is not a continuous form, it has the type of categorical. Either it could be a binary form, okay, which is 0, 1, or you can say yes, no form, or either it could be having the multiple nominal form, like we can say that the person is married or are not married or are divorced. So we have may have the multinomial form, or we may have the dependent variable in a ordinal form. So the main thing is, if the dependent variable having the categorical form, then in that particular case we can apply the logistic regression, okay, in order to classify whether your particular data point is going to be part of class 1 or the class 2, or you can say part of group 1 or group 2, okay. Whereas the independent variable could be all are continuous, could be having the mixed form. So the major difference between the logistic regression and the linear regression is that is the type of the data in the dependent variable we have. If the dependent variable is the continuous type of variable, then we can apply the linear regression. But if the dependent variable having the form of uh, binary form, like yes, no, defective, non-defective, okay, good or bad, right? We have the binary options, then we can apply the logistic regression, okay, or either it could be the multinomial form or ordinal form, right? So the main thing is we can use this logistic regression to classify the thing. Okay, like as I am telling you regarding the binary logistic regression, our dependent variable may have the two option, either we are saying yes or a no. So we can classify whether the particular data set is the part of the yes group or a no group. Okay, so that's why we are saying it is using to classify the data point whether it is going to be lie on this group or a no group. Okay, as you can see from this particular group. So basically what we are doing, we are finding the probability that what is the chance that those data points are going to be part of this part or a this part. So that's why we are saying that basically the logistic regression using the concept of the probability in order to identify or in order to classify whether the data set is going to be the part of this portion or a this portion. Okay, so now if we are seeing that what is the difference between a linear and logistic regression? So one of the difference we have already discussed, that is in a linear regression, the response variable or a dependent variable must be in a quantitative nature or a continuous type of form. Whereas in a logistic regression, the response variable must be having a categorical form, or you can say the attribute form. Okay. Furthermore, in a linear regression line, when we are predicting the dependent variable, which means when we are predicting the y variable, which is a dependent variable, based on the in multiple independent variable. Okay, so actually based on these independent variable, we are predicting the actual values of those that dependent variable. Okay, which is a continuous variable. Whereas in a logistic regression, while using those independent variable, we are not predicting the actual values of the dependent variable, but we are basically predicting the probability of occurring that particular dependent variable, which is a y variable. Okay, which mean we are trying to predict, if I am talking about with respect to the binary logistic regression, whether that data point is going to be lie in class A or class B, which mean in yes part or a no part, right? So another difference is when we are modeling this linear regression, so graphically we can represent in a straight line. Okay, that is a linear line. Whereas when we are develop, uh, plotting that this logistic regression, so this logistic regression is not the linear line but the S curve. Okay, so how it is look like and why we are saying it is going to be used the S curve. So here is the example. So right now in this particular example, I am going to consider my dependent variable, which means the response variable must lie between 0 and 1. Okay. So if you can see that these green dots, which is the x-axis and y-axis, and I want that my y variable must be lie between 0 or 1, which means against this x, the value of y is 0. Against this x, our value of y is 0. Okay, and so on. Similarly, against this x, our value of y is equal to 1. So there is no value of y in between. So if I am going to apply the linear regression in this particular situation, so I may get the value of y out of this particular range, maybe more than 1, maybe less than 0. Okay, so that's why we cannot apply the linear regression in this particular situation, which means we cannot use the linear regression to classify that whether the particular x value is going to be lie in this particular um, group of data points, which mean in the cannot predict the dependent variable y. Okay, similarly cannot predict the dependent variable whether it is going to be lie in the zero class. So for that we need such equation or such function that should be lie between 0 and 1, as we can see over here. So if I'm going to use the linear line, so then it might be possible we can cross this range. Okay, so for that we are basically using the S curve, which you can see that either the value is going to be 0 or the maximum it could be 1. So with the help of that one, we can easily predict based on the x variable that what would be the probability of y given that particular x. Okay, so on the basis of that we can classify whether based given that x value, whether the probability of y is towards the 1, which means whether we can classify that is going to be part of this portion or whether it is going to be part of this portion, which means to the class of 0. So as you can see with the help of this particular graph, we can say that whether it is going to be part of this class or a this particular class. Okay, now the question is, what is the name of this function? As we can see that the straight line is basically a linear regression, and the straight line, this is called as, so this S curve is basically called as a sigmoid function. Okay, so how we can convert this linear line into this sigmoid function? That is with the help of this one. Okay, so as we know that the function of this linear line is y is equal to beta naught plus beta 1 into x1. So this b naught is the intercept where basically against what value of y the x, basically the line is crossing the y. Okay, so this is basically each value of x, how much the y is going to be increase or decrease, that is based on the slope. Okay, so this is how we can find out the logistic regression model. That is basically P is the probability of Y which we are predicting. That is, this is the sigmoid basically function, which is basically 1 over 1 plus e power minus Y. And we are replacing the Y with this equation. So that is called as the logistic regression, right? Okay, so now the question is how many type of logistic regressions we have. As we have discussed briefly earlier that we have the three types of logistic regression. One is the binary logistic regression, we have nominal logistic regression, we have ordinal logistic regression. So remember that how we can say that should we apply the binary logistic regression or a nominal or a ordinal, that is totally depending upon the type of the dependent variable we have. If the dependent variable having the only two options, either go, not go, pass, fail, yes, no, should I buy the product or not buy the product, is it a male or a female, right? So if the dependent variable having only the two categories, then we should apply the binary logistic regression. If the dependent variable has more than two levels, or you can say the two categories, and they do not have any order preferences, okay, so the unordered categories, in that case we should apply the nominal logistic regression, which is normally called as multinomial logistic regression, right? Okay, if the dependent variable having the ordered categories, like as I am giving the example of that, if we are categorizing whether it is the poor, good, or excellent, okay, or we can say dissatisfied, neutral, and satisfied, and we want to identify whether the data point is lying in the class of dissatisfied or a neutral or a satisfied, so then we should apply the ordinal. But in this lecture, I will mainly focusing on the binary logistic regression when our dependent variable having only two options, either yes, no, good, or bad form, right? Whereas our independent variable could be having any type, whether they could be have the continuous type or whether they may have the logistic or the nominal type. Okay, so for that, we are considering example. So the example is a marketing consultant for a cereal company. Okay, he is basically investigating the effectiveness of the TV advertisement for a new cereal product. Okay, so the consultant shows that advertisement in a specific community for 1 week, and then consultant randomly sample the adults as they leave the local supermarket to ask whether they saw the advertisement and bought the new cereal or not. Okay. The consultant asked the adults what their annual household income is. So based on this data, the consultant want to know whether that particular adult is going to buy the cereal or not. So basically they have collected the data that what is the income level, household income, whether that adult having a children or not, whether that particular adult has viewed that particular ad which we have shown on the television or not. Okay, and based on that data, we have collected whether he or she bought the product or not. Okay, that is a serial, whether he bought or not. Okay, so based on that, I want to know if I am going to take any random adult and I want to know whether that person is going to be buy that particular cereal or not. So for that, I am going to use this data set and trying to implement in the regression, and we will fit the logistic regression, and we will predict that under what factors we can use in order to identify whether that particular adult is going to buy the product or not. So for that, let's open the R file. Okay, so that is this one. Okay, so first of all, what I am going to do is I am going to opening this particular serial purchase.csv file which I have available over here. So in this serial purchase.csv file, we have the four variables. So the bot is basically our dependent variable. That zero is basically indicating that this person didn't bought the cereal, whereas one is basically indicating that the person has bought the cereal. Okay, so similarly we have the income, similarly we have the children and the view ad. Okay, so, so for that, first of all, I am reading this CSV file. So how we can do that? So I can use either this particular function, which is basically read.csv as the file we have in the format of CSV. And then within this function, I am calling another function that is called as file.choose. Okay, so with the help of this particular function, actually, I will get another pop-up window where it is going to give me the option that select the particular file which against which you want to run the analysis. And then header is equal to true is basically indicating that the first line of the data is basically the name of the variable. Okay. And then I am saying that read that data file and store into the variable called serial PUR, which is basically the purchase. Okay, so if I run this one, so you can see that we have a pop-up menu, pop-up window, and then I can easily select this data file. Or you can also do another way to read this data file, because the data file is available on the same folder in which I have developed my R Studio project. Okay, so if I just run it read.csv, and in double quotes I should write down the name of that data file. Okay, and header is equal to true, so R is going to automatically understand that, so I should read this data file because this data file is available within this folder. Okay, if that data file is not available within that folder, then we need to give the entire path where that particular data file is available. So it's up to you. Either you can use this particular option to read the data, or you can set to load the data, or either you can use the second option. So we have already read the data with the help of the first command, and now our data is available in this variable. So the first thing, I want to view that data set within the R. Okay, so how can I do that? We have the function called view, and in this function, I'm calling the variable called serial. So if I run it, so we can see that the entire data set, the first variable we have the bot, another one is the income, the children, and the view ad. Okay, so let's first apply this binary logistic regression. So how we can apply the binary logistic regression? The function is GLM. So GLM stands for generalized linear model. Okay, like if you want to apply the linear regression, then we are going to apply the LM, right? But right now we want to apply the logistic regression. The function is GLM. Okay, and then we are mentioning the name of the variable which we have the dependent variable. So this is the dependent variable which is a bot. Then we have the tilde sign. Okay, and then we have to write down all the independent variables we have. So we have the three independent variables. As we can see that we have the income, children, and whether the person has viewed that ad or not. Okay, so we have the three variables, that is income, the first independent variable, plus the second, plus the third. So we are incorporating all the variables as independent. So I am trying to fit this logistic regression model. So I want to try to predict whether the particular person is going to bought the cereal or not based on this income, whether that person having the children or not, whether they have viewed the ad or not. Okay, because I want to apply the logistic regression, so that's why I have to mention the family. Okay, so the family is going to be equal to the binomial. Okay, so as soon as we are going to write down this one, so basically R is going to understand that the dependent variable is basically in the form of binary. Okay, and then we are mentioning the data variable, which means the variable in which we have the entire data set. Okay, so after running this logistic regression model, I am storing the results of this logistic regression in a variable called blg1. Okay, so if I run this one, right, and even if I write down blg1, so I can see the results. So what are the results? I can see the coefficients, which means this is the intercept, this is the coefficient for income variable, this is the coefficient for children, those having the yes, which means those have the children's, and this is a coefficient those adults who has viewed that particular ad, right? But I want to see the results in more detail. This is just showing me the coefficients, and another thing is it is going to giving me the basically null deviance model results and the residual. So what is that? We are going to talk about in a minute, but let's first of all basically trying to get the results in a detailed form. Okay, so how we can get that one? That we can get with the help of this function. So in a summary, we can write down the name of the variable in which we have the results of that fitted model. So as you can see that we have the entire basically logistic regression model results. Okay, so let's go to the PPT and try to understand. Okay, so how we can interpret those results. So so as we have already seen that with the help of this command we have read the data, with the help of this command we have viewed the data, with the help of this command we have applied the logistic regression, and with the help of summary we get the result, and those results are basically this one. So what we want to see first of all, before going to check the values of the parameters of the model, first of all, we want to see that whether this model is a good model or a not. Okay. So how we can check this one? That we can check with the help of two approaches. The first one is the deviance approach. Another one is with the help of Akai information criteria. So let's first of all, we should check with the help of this deviance approach whether the fitted model which we have right now fitted, is it a good model or not. So how we can do that? So we have in the output of the logistic regression, we have two types. One is null deviance, another one is a residual deviance. Okay, we are going to compare these two values. Okay, the smaller the deviance value, the better the model is. So remember that the null deviance means such logistic regression model which having no independent variables. So that means so the logistic regression is fitted based on the dependent variable that is bought, and independent variable is considered as a constant which is one. Okay, so it is comparing these two models when we have the bought, okay, and when we have this entire model. Okay, so as we can see from this deviance results that our residual model, which mean our this model having the smaller deviance, that mean our this fitted model which we have fitted right now, where our independent variable is income, children, view ad, okay, is better than the null deviance model. Okay, so that is indicating this model is good compared to the null model when we do not have any independent variable. Okay, so let's check this one again with the help of second approach, that is called as Akai information criteria. So how we can do that? So let's go to the R code again. So in a R code, what I am doing is, so I am first of all fitting the null model separately. Okay, so how can I do that? Again, GLM, that is basically generalized linear model. We have a dependent variable tilde sign 1, that is basically indicating that I right now I am not considering any independent variable, only constant is going to be considered as an independent. And then we are mentioning the name of the variable in which we have the data, and then we are applying the binomial function. Okay, so we can do that this way, or either we can go, even this approach can also apply over here as well. Okay, so if I run this one, so we are getting the result, and then we can apply, get the results of this null model, which is this one. Okay, so what I am going to do is, we already have the summary results when we have fitted this model. Okay, that is this one, and we have the summary results when we only have the intercept and not other any independent variable we have. So what we are going to do is, we are going to compare the Akai information criteria values as I shown over here in my PPT as well. So the model having the smaller information criteria is the good model, is the better model. So as you can see that the null model, which having only the constant independent, okay, in intercept, whereas the model which we having the three independent variable having the smaller information criteria compared to the null model. So that is also indicating that our fitted model is better compared to the null model, right? So once we have seen that one, that our fitted model is good one compared to our null model. So now the next step is, we want to check that whether this independent variable is significantly affecting our dependent variable, which means whether the income variable can be significantly contributing in order to predicting that whether the person is going to buy the cereal or not. Okay, similarly, whether the particular adult who have the children, okay, is going to predict whether the person is going to buy the serial or not. Same is the case for the view ad. So as you can see, the values of this p values. Okay, so with the help of this one, we can check this one. So how we can do that? The basic idea is, if the p value is basically greater than or equal to your pre-decided alpha, then we will say that that particular variable is not significantly affecting our dependent variable. But if the p-value is less than your pre-decided alpha, then we can say that that particular variable is significantly affecting the dependent variable. So as you can see that our incomes probability p-value is greater than our 0, or either you can take the alpha 1%, okay, 0.1%, or a 1%, or a 5%, or a 10%. So that means this income is not a significant factor. Whereas the person who having the child, or the person who has viewed the ad, is a significant variable against the 10%. Okay, so that means, uh, so as consultant, what is going to do is, that consultant need to refit this particular model is, okay, in order to know, we are going to refit the model without this income variable, because this income variable is not a significant factor, right? So we are going to refit the model, and that refit model is going to be called as model number 2, and we are going to fit that model with the help of the independent variable, the children, the adult who have the children, okay, as well as the view ad with respect to the view ad variable. So let's fit the model number 2. Okay, let's move to the R code. So now I am fitting the model number 2. So again, I am calling a function called GLM, which is generalized linear model. We have a dependent variable bot. Okay, and we have the two independent variable, which is the children variable. Another one is view add, and then I am mentioning family is equal to binomial and the name of the variable in which we have the data set. Okay, so right now in this model, we are not considering one of the variable, which is income, as we have already seen that that particular variable is not a significant factor in order to find out whether the person is going to buy that cereal or not. Okay, so after fitting the model number 2, I am getting the result of that model as well. Okay, so that is basically this one. So first of all, what we are going to do is we can easily see that after fitting the model number 2, we can easily see that against the basically 5%, okay, our p values are less than this 5%, which is indicating that the person who having the children or the person who has viewed the ad is significantly affecting the decision of whether the person is going to buy the product or not. So basically we are trying to say is that the children variable and as well as the view add variable is significantly predicting, or you can say affecting, the response variable, which is the bot variable. Okay, now the main thing which we want to know is that whether this second model is good enough compared to the model one that we can use in order to predict that any random person who has the children and who has viewed the ad is going to buy the product or not. Okay, so for that we need to compare the model 1 and the model 2. Okay, so how we can do that? So what was the model 1? The model 1 was when we have the independent three independent variable, which was income, children, and view aid. Okay, and we have seen that the income was not a significant factor in that one. So that's why we have fitted the second model, in which we have the independent variable is children and view add. Okay, and we have seen that this model is having the more significant factors. Okay, but I want to compare whether the model 2 is good compared to model 1 or not. So for that, what I can do is that I am going to call a function called ANOVA, and then the name of the variable in which we have the results of model 1, again the name of the variable in which we have the model 2, and then in order to compare is basically we are going to apply the test called chi-square test. So if I run this one and I am getting this one, so let's go to the PowerPoint in order to interpret these results. Okay, so basically we are checking that whether the model 1 is good or the model 2 is good. As we know that the what was the model 1? The dependent variable was bought and the independent was income, children, and view add. Whereas model 2, the dependent variable was bought, whereas the independent variable is children and view add. Okay, so over here, as we can see that in this pair of models, the model 2 is the part of the model 1. Okay, when this is the case, basically our H naught statement is the smaller model is true, whereas the H1 is the larger model is true. So what does that mean? Basically, based on this p value, we are going to decide whether this smaller model is good fit or whether this larger model is good fit. So how we can decide it? If this p value is greater than or equal to alpha, which is basically we are considering right now 5%, so you can also take it 1% or whatever you want. Okay, so let's say based on this 5%, I am deciding whether I should accept H naught or reject H naught. So the general criteria is if this p-value is greater than or equal to the alpha value, which is right now 5%, we will say except H naught. Okay, so which is over here. So this p-value is greater than the 5%, so we will say except H naught. And H naught statement is basically saying that the smaller model is true. So that means the smaller model is basically model 2. So that is basically indicating that compared to model 1, model 2 is a good model for this data set in order to predict whether the particular person is going to buy the cereal or not, right? Now, let's use this model too and try to interpret its parameters. Okay, because these are the parameters which we want to estimate, and we want to know how much the particular variable the children is going to affect the variable on the board. Similarly, how much this person who has viewed the ad is going to affect on the person who is going to buy the particular product or not. Okay, for that we cannot use these estimates straightforwardly. So the better is that because we are basically trying to identify or trying to predicting the probability, so we will try to use another concept which is called as the odd ratio. So what is the odd ratio? Basically, the odd ratio is going to quantify the strength of the association between two events. Okay, so what kind of two events? Like right now, the two events are basically whether the person is going to buy the cereal, okay, buy the cereal, or given that it is not going to buy the cereal. Okay, so these are the two events, right? So based on the odd ratio, we can check that whether the person higher the chances that it is going to buy, or is it the higher chances that it is not going to buy. So how we can decide that? We can decide with the help of this odd ratio. If the odd ratio is equal to 1, then there is a equal chance that person is going to buy the cereal as well as that the person is not going to buy the cereal, which means that particular you can say factor or the variable having no effect on the response variable on the outcome. Whereas if the odd ratio is greater than 1, then the upper side of the variable having the higher chance of happening. That means then there is a more likely that the person is going to buy the cereal, okay, compared to the that it is not going to buy the cereal. But if the odd ratio against the particular factor is less than 1, then it is less likely to buy the cereal or compared to not buying the cereal. Okay. So how you can find out these odd ratios? That is basically we are finding with the help of these parameters, which mean these coefficients. So first of all, I am trying to identifying these model parameters coefficient. I am extracting these coefficients. So how can I do that? With the help of COEF function, that is the coefficient. So as you can see that this is basically the first coefficient, this is the second coefficient, this is the third one, right? Okay, in order to find out basically these coefficients, if we take the exponential power of these coefficients, we would be able to get the odd ratio. So that's why I'm using exponential function of these coefficient, which means e power this, e power this, e power this. So we will get these odd ratios. So right now our independent variable is that the person having the children is yes, okay, compared to the children they have no. So that means 5.1628 times the person who having the children is more likely to going to buy that cereal compared to the person who do not have the children. Similarly, there is a 3.0218 times more likely that the person who has viewed the ad is going to buy the cereal compared to the person who do not have viewed that ad. Okay, so I hope you got the idea that how we can perform the logistic regression, how we can interpret the results of those logistic regression. So thank you so much. See you in the next video.